Forget teleportation for a second. Let's talk about something that's been sitting in your chest this whole time, about 10 liters of air moving in and out, and right now in your lungs, there are more molecules than there are grains of sand on every beach on Earth combined several times over. And here's the thing, not one of them is you. You couldn't pick your own electrons out of a lineup because they don't have names, they don't have serial numbers. They are, in a way that has no classical analog, perfectly, absolutely, irreducibly identical. That fact that electrons aren't just similar but identical turns out to be the deepest reason you can't be teleported. Not engineering problems, not energy costs, not bandwidth, the structure of reality itself. Let me show you why. Start with something simpler. 2 red billiard balls. Are they identical? Not really. One was scratched in 1987. One has a slightly different mass, maybe a fraction of a gram heavier. Even if you manufactured them to extraordinary precision, they have histories, trajectories, positions. You can paint a tiny dot on one and track it. They're distinguishable. Classical mechanics runs on this. Every particle has a trajectory, a continuous path through space, an identity that persists like a bead on a wire. Now go down to electrons. 2 electrons, same mass, same charge, same spin, not approximately the same, not same within measurement precision. Exactly, provably, fundamentally identical. There is no property, none, that distinguishes one electron from another. They don't have histories you can track. They don't have tiny scratches. The universe doesn't keep a ledger with their names. You might say, fine, they're very similar. But very similar and identical are different things. In classical physics, very similar is the best you get. In quantum mechanics, identical is a statement about the architecture of physical law. Here's how we know it matters. In 1926, before we fully understood what we were dealing with, physicists were trying to calculate the thermodynamic properties of a gas, entropy. Specifically, Josiah Willard Gibbs had already noticed something troubling decades earlier. If you mix 2 containers of the same gas, the entropy calculation comes out wrong. You get a paradox. Mix 2 liters of nitrogen with 2 liters of nitrogen, and classical statistics says entropy increases. The particles can now spread across the larger volume. But physically, nothing happened. You just removed a partition between identical gas. The entropy shouldn't change. Gibbs patched it by hand. He divided by the number of ways you could rearrange the particles. It worked numerically, but he didn't know asterisk. Why asterisk? He was fudging. The answer came from quantum mechanics. Particles of the same type are not just similar. They are genuinely, physically indistinguishable. When you swap 2 electrons, not metaphorically, but in the mathematics that governs how systems evolve, the swap is physically meaningless. There's no observable difference between electron A at position 1 and electron B at position 2 inches and electron B at position 1 and electron A at position 2. Not because we can't tell them apart, because there's no fact of the matter to tell. This sounds like philosophy. It isn't. It has hard, measurable consequences. When you write down the quantum state of a system of identical particles, you have to account for this symmetry. The wave function, the mathematical object encoding everything about the system, must behave in a specific way when you swap 2 particles. For electrons and particles like them, called fermions, the wave function must change sign, flip, invert. For particles like photons, called bosons, it stays the same. The sign change for fermions is everything. If you try to put 2 electrons in exactly the same quantum state, same position, same momentum, same spin, you immediately hit a contradiction. Swap them, and you get the negative of what you started with. But if both electrons are in the same state, swapping them should give you back exactly what you started with. The only number equal to its own negative is 0. The wave function is 0. The probability is 0. The state doesn't exist. This is the Pauli exclusion principle. And Wolfgang Pauli worked it out in 1925. 2 identical fermions cannot occupy the same quantum state. Not won't, cannot. The mathematics forbids it the same way 2 plus 2 is forbidden from equaling 5. Now, why does this kill teleportation? Here's what teleportation would have to mean. Real teleportation, not the quantum teleportation of information, which is real and fascinating but different. You want to take a person, call her Maria, disassemble her here in Karachi, transmit information about every atom, and reconstruct her in London. Maria's body contains an almost incomprehensible number of atoms: hydrogen, oxygen, carbon, nitrogen, calcium, a dozen other elements. For the teleportation to work, You need to reconstruct her atom by atom, electron by electron, in exactly the right configuration. But here's where indistinguishability bites you. The electrons you're using to reconstruct Maria in London, where did they come from? You either transported her actual electrons, or you used different electrons, but different electrons is meaningless. There are no different electrons. All electrons are the same electron in the sense that none of them have identity. If the reconstruction uses electrons from London, which you do, because shipping matter across the Atlantic is the whole problem you're trying to solve, you are assembling Maria from particles that have no connection to the original Maria. You say, fine, that's fine. What matters is the pattern, not the particles. The configuration, the information. And now we have to have an honest conversation about what information means here and where the Pauli exclusion principle shows up in ways that make you uncomfortable. Every electron in Maria's body is in a specific quantum state. Its position is described by a probability distribution. Its spin is up or down or in superposition. The state of her entire electron system is a deeply entangled, anti-symmetrized combination of all possible ways to assign those states to those electrons, because the electrons don't have labels. When you try to read Maria's state to transmit it, you immediately hit the Heisenberg uncertainty principle. You cannot simultaneously know the exact position and exact momentum of any electron. You can measure one precisely only at the cost of the other. To reconstruct Maria perfectly, you'd need both, because the exact position determines which orbitals her electrons occupy, and their exact moment determine how her biochemistry will evolve in the next fraction of a second. The no-cloning theorem, proved by Wouters and Zurek in 1982, makes this precise. You cannot copy an unknown quantum state. The mathematics is tight. Any operation that copies an arbitrary quantum state exactly leads to a contradiction. So you can't read out Maria's complete quantum state without destroying it, which means you can't transmit it without first demolishing the original. Fine, the teleportation proponent says, we destroy the original. We measure as much as we can, transmit, reconstruct. The quantum teleportation protocol does exactly this for individual qubits. One quantum bit of information, teleported exactly, original state destroyed, using entanglement as the channel. Does this scale to Maria? Let's be honest about the numbers without writing any down. The quantum state of a single hydrogen atom is already infinite dimensional. The electron's wave function is a function spread over all of space. To completely specify Maria's quantum state, you'd need, in effect, infinite information. Not a lot of information, infinite. Continuous variables require infinite precision. In practice, you'd truncate, settle for some finite precision. But here's where the Pauli exclusion principle re-enters and says something sharp. Maria's electrons aren't in arbitrary states. They're in states constrained by the exclusion principle, distributed across atomic orbitals according to specific rules, organized into the chemical structures that make her asterisks. The specific distribution of electrons across those orbitals isn't just a technicality. It is the chemistry. It's why carbon forms 4 bonds. It's why DNA has the shape it has. It's why protein folding works the way it does. When you reconstruct Maria in London, you need every one of those electrons in exactly the right orbital, with exactly the right spin, off by one quantum number in one electron, somewhere in one of her 100 trillion cells, and you don't have Maria, you have something, not her. And here's what nobody talks about. Even if you got the reconstruction right, you'd have created a new person who is, as far as physics is concerned, identical to Maria. The original was destroyed. The copy believes it's Maria. There's no fact of the matter distinguishing original from copy. That's indistinguishability again, working at the macroscopic level. Maria's atoms are not special. The atoms in your body right now are not the atoms that were there 7 years ago. Almost all of them have been replaced. What makes you you is not the particles, but the pattern. But if it's the pattern and the no-cloning theorem says you can't copy the quantum pattern exactly, what exactly are you teleporting? Let me push this deeper, because this is where it gets genuinely strange. The Pauli exclusion principle isn't just a rule that governs electrons in atoms. It governs the structure of matter at every scale. White dwarf stars, objects about the mass of the sun compressed to the size of the Earth, are supported against gravitational collapse by electron degeneracy pressure. This is not a force in the usual sense. There's no force carrier, no particle being exchanged. It's purely a consequence of the fact that electrons are fermions. You cannot compress them into fewer states than they currently occupy without violating the exclusion principle, and the universe simply doesn't do that.
Neutron stars are supported by the same logic applied to neutrons. A neutron star packs more mass than our entire sun into a sphere you could drive across in a few minutes. The density is so extreme that ordinary matter, atoms, nuclei, electrons in their usual orbits cannot exist. What's left is essentially one enormous atomic nucleus, held up not by any conventional force but by the exclusion principle applied to neutrons. When neutron degeneracy pressure fails when the star is too massive, you get a black hole. The exclusion principle has a limit. Past a certain mass, gravity wins. The same principle that prevents teleportation holds up dead suns.
There's a connection worth tracing. The exclusion principle comes from indistinguishability, which comes from the fact that particles of the same type are not just similar, but actually identical. Classical physics had no mechanism for this. Quantum mechanics demanded it. The wave function of a multi-particle system must be either symmetric or antisymmetric, under exchange, and the type of symmetry determines the statistical behavior of the particles entirely. Boson's symmetric wave function allow any number of particles in the same state. That's why lasers work. You can put an enormous number of photons into exactly the same mode of light, marching in lockstep, which is what makes a laser and not just a flashlight. That's why liquid helium cooled below a certain temperature flows without any friction at all. The atoms condense into the ground state collectively, and there's no mechanism to knock them out of it. Fermat's antisymmetric wave function do the opposite. They push apart into different states. They build the periodic table. They make chemistry possible. They make you possible. Now here's the thing about teleportation. I want to push to its logical conclusion. Even if you could solve the measurement problem, even if you could somehow extract Maria's quantum state without the no-cloning theorem sinking you, you face an entanglement problem that compounds everything. Maria is not an isolated system. Right now, her electrons are weakly entangled with the electrons of the air around her, the floor beneath her feet, the photons passing through the room. Not strongly. The decoherence time for macroscopic objects is vanishingly short, far shorter than any measurement you could make. But the point stands. Her quantum state is not just a description of her particles. It includes correlations with the environment. If you want to teleport Maria faithfully, physically faithfully, not just pattern faithfully, you'd have to capture the state of her entire environment as well. And her environment is entangled with a larger environment. There's no clean boundary. The wave function of the universe doesn't have a Maria region you can excise without affecting the whole. This isn't mysticism, it's entanglement, which is the most tested non-classical prediction in physics. Bell's theorem, proved in 1964 and tested definitively by Alain Aspect in 1982, and by loophole-free experiments in 2015, quantum correlations between particles cannot be explained by any local hidden variable theory. They are real, they are non-local in a specific technical sense, and they mean that the state of Maria is not a well-defined isolated quantity. So where does this leave us? Quantum teleportation of single quantum bits works. It's been done with photons, with trapped ions, with superconducting circuits. In 2022, a team teleported quantum states across a fiber network spanning dozens of kilometers in the Chicago area. The physics is confirmed. Scaling to a human body requires perfect quantum state measurement of an incomprehensible number of atoms, impossible due to the no-cloning theorem, a channel capable of transmitting infinite information, impossible due to bandwidth, reconstruction in exactly the right quantum states obeying the Pauli exclusion principle for every electron requires a precision that has no upper bound, disentanglement from the environment requires capturing the state of the universe. Each of these is not an engineering challenge. They're not the Wright brothers' problem where the physics was fine and we just needed better materials. They're barriers in the structure of the theory itself. But here is what I actually find interesting. Not the impossibility, but what the impossibility reveals. The fact that you can't copy a quantum state tells you that quantum information is not like classical information. Classical information is copyable. That's how computers work, how books work, how memory works. Quantum information is not. It's asterisk, physical asterisk, in a way that has no classical analog. The no-cloning theorem says the quantum state is not a description of a particle. It is the particle. The fact that two electrons are indistinguishable tells you that identity, in the classical sense, the sense we apply to people, to objects, to things that persist through time, is not a feature of the fundamental layer of reality. Things at the quantum level don't have identities the way you have an identity. The category of individual breaks down, and the Pauli exclusion principle, The consequence of antisymmetry under exchange tells you that the structure of matter, the periodic table, chemistry, biology, you, is a consequence of something that has no classical explanation. It's not a force, it's a symmetry. The universe is organized the way it is because the wave function must change sign when you swap identical fermions. Wolfgang Pauli won the Nobel Prize in 1945. The exclusion principle he identified in 1925 from spectroscopic data before Schrödinger's equation, before matrix mechanics was complete, is woven into the deepest fabric of physics. Every atom in your body is the shape it is because electrons cannot pile into the same quantum state. Every chemical bond, every protein, every thought you've had, you can't be teleported because the physics that makes you possible also makes copying impossible. The same antisymmetry that builds your atoms prohibits perfect reconstruction. The same indistinguishability that makes chemistry universal makes quantum states impossible to clone. That's not an accident. It's a single coherent structure. I've been asked whether this makes teleportation forever impossible, or just impossible with current physics. The no-cloning theorem is a theorem. It's derived from the linear structure of quantum mechanics, which is the most precisely tested theory in the history of physics. If quantum mechanics breaks down at some deeper level, and it might, we don't know, then the no-cloning theorem goes with it. But then we're not doing quantum mechanics anymore. We're doing something else entirely. What we don't know, whether there's a deeper theory underneath quantum mechanics, whether the indistinguishability of particles is genuinely fundamental or emerges from something more basic, whether the continuous infinity of quantum state space is real or an approximation. These are open questions, honest ones. What we know, every experiment we've done is consistent with quantum mechanics. Every test of the exclusion principle has confirmed it. Every attempted violation of the no-cloning theorem has failed, in exactly the ways the theorem predicts. The universe isn't hiding the keys to teleportation in a drawer we haven't opened. The prohibition is in the mathematics that describes everything we've ever measured. Maria can walk to the airport,